Welcome to the Lippis Report.
I am really excited about this segment because we're going to be demonstrating the active-active features of Brocade VCS architecture with Jivan Sharma and also Viral Vimawala. Hi everyone, we're now about to show you the layer 1 multipathing test, and also there are two things with this. We want to show how easy it is to do auto provisioning and also how easy it is to create a Brocade trunk. So with me is Jivan. Say hello.
Hello. Hi folks, so we're going to show what Nick just talked about. So
excellent. Yeah. So first, I want you to show us that we have a switch, but it's not connected to the network, and how easy it is to configure it. So first, let's make sure that everyone knows that it's there, but it's not connected.
Sure. Okay. Let me show you, Nick. So look at this. So here's my fabric. So if I do show VCS, it shows you the fabric. So we have 4 switches, 3 switches in this fabric.
So there are 4 switches here. It shows the status of being online.
Yeah.
And then these are their host names, like right there.
Right.
Okay.
Exactly. And then I'm going to show you a switch which hasn't yet joined the fabric. So you do the show VCS, and here you see that this is a online switch is online, but it hasn't joined the fabric. There is no fabric. And what we're going to do now next is we're going to connect a cable from this switch to this switch, and then we'll see how and then we'll show you how it becomes a part of the fabric, and it becomes a node in the fabric without any configuration required.
Excellent, great. So, and I'm the one who's going to actually connect the cables to show you really how easy it actually is. So let's go into the lab. Here we go. And now, let's go see if that came up on the network. And we're back. So now I want to basically ask Jivan to basically look at and show us if that switch now is part of the fabric.
Sure, Nick, let's take a look. So let's see what happened. Show fabric ISL, and here you go. So you look at this. Okay. Yeah, that's the switch you added, and see there's a 10 gig link. Yeah.
Then there's a trunk there. Okay, great, and it's the 36 VDX.
Yeah, that's part of the fabric now. So let's see on this one also. So show fabric ISL, and you see there's a 10 gig link. Yeah, so it's formed the fabric now with the.
Very good. Yeah. Excellent. So all I had to do was just connect the 2 switches together with a 10 gig link cable, and it's part of the network. What if we want to add bandwidth between that switch and another switch? So how do we create a trunk?
No problem, simple. Just go and add the cables, more cables and more bandwidth.
Do the same thing again?
Yeah.
Okay, great. All right, we're going to do that. Okay, great. So now you saw that the 6700 came up, part of the network with a 10 gig link. Let's increase the bandwidth. Let's create a Brocade trunk. And the way we do that is that we take another cable and we just connect the 2 switches together. So we connect the 6700 into an 8700. Let's add the bandwidth and let's see what happens. Okay, so here we go. That's one line. There's the second one. All right, so let's take a look. And so we should have a 20 gig link between the 8700 and the 6700. Okay? Okay, great. So we're back. And so now I just connected 2 switches with 2 10 gigabit Ethernet links, no CLI command inputs whatsoever. We should see a 20 gig trunk. So, Jivan?
Let's see. I mean, there's no CLI command needed, so it should be 20 gig. So let's run the command and check what's the bandwidth. Okay, there you go. So it's 20 gig.
Yeah. So great. So we have a 20 gig trunk now between the 2 switches, and it's the VCS fabric that basically recognized it and then increased the bandwidth for it. And there it is again, on that switch. So great. So that's it. That's the auto provisioning. Easy to add a switch and also easy to add trunk bandwidth as well. So I'm here with Javon, and we're going to talk about layer 2 multipathing. Now this is really important because remember the whole point about multipathing is to get rid of spanning tree. And so what we did in spanning tree, we had an active standby configuration. We have active now. So what we really want to see is that when we have a certain amount of traffic coming in, that it's being evenly distributed across a group, a trunk of active ports. So now, we just did in the level 1 multipathing, we showed how easy it was to create a trunk. Well, basically, we're now taking that and creating a network made of trunks, right? So, Javon, what I wanted to ask you to do is if you can show me how much traffic we have coming into a couple of switches that we've created trunks for already.
Okay, let me show you then what is the traffic coming in. So, we have 2 switches where the traffic is currently coming in on the on 2 port channels. Okay. So let's look at this one. So if you look at this, the traffic coming in is on the first 2 port channels. So we have 23 gigabits of traffic. Okay. So that's coming in on first 2 port channels. So each member is getting this much traffic. So these are the 6 member links, 3 on each port channel.
Good. And that's the Ixia gear is generating that traffic into like this switch.
Yeah, exactly. And then we have another switch which is also sending the same traffic. So if you and they are sending to each other. So this is one. This one also has those 2 port channels sending this traffic. Yep. These are the member links.
Okay, and these are the. So basically, we have 6 10 gigabit Ethernet links. So we have 60 gigabits of traffic, and that's a member as you define it.
Exactly.
Okay,
yes.
Very good.
Yes.
Okay, great. So that's what's coming in. So let's see what's going out. So going out meaning that how much is coming into like the 8770s.
Perfect. Yeah. So let me show you. So we have a layer 2 multipath here. So what we have is within the fabric, we have got each of the top of the rack switch connects to 2 switches. So you see there's 60 gig aggregate bandwidth. Yep. So going to in each direction.
Great. And so we have 60 gigabits each into the fabric.
Okay. Now I'm going to show you how the traffic is going out. So we can check on this one, for example. So, okay. So when we look at this one, so this was the traffic coming in. Now this is the traffic which is going out. Okay. So these are your links. Great. So the first 6 are going to the first switch, and the second 6 are going to the second switch. And so you see that the traffic is getting load balance. 50% of the traffic is going to switch 1. 50% is going to switch 2. And that 50% traffic is now split across those 6 links, almost equally divided across those six links.
Yeah, and that's very, very important. Again, like if this was spanning tree, you'd see 100% and 0. And other hash kind of MLAGs, you'd see maybe 80% in a couple of links and maybe 20% in another few links. So what we have here is a full utilization and distribution of the traffic across these trunks. So that's layer 3 multipathing.
Absolutely, yeah.
Great. Thank you. This last test in the active series here is unique to the industry, and Brocade brought it to the marketplace. It's what we call the layer 3 active end gateways test. And so this is how we designed it. So take a look at the configuration. So first we start down here on the bottom. It's the Ixia gear with multiple virtual servers. Now, this is normally kind of the top of rack scenario, so we have servers connected into, could be a 6700 series or an 8700 series switch. And then those are going to the core of the network. And in here we have 3 different default gateways. And so these are 8700s, all connected with 10 gigabit Ethernet links. And you could have more than just these 3, but we're just showing these 3. So what this basically, the protocol that this is modeled on is VRRPE, or extended. And what we're basically doing is creating one virtual IP address across all of these different default gateways. Now this is extremely useful in layer 2 extension kinds of configurations, and also for those who are really in the know, tromboning as well. So what we basically are showing here is that we're going to inject a lot of traffic through the Ixia gear up into like the 6700 or 8700 with the virtual IP address. And what we're going to show is that as we approach or exceed the link of any one of these default gateway links is that we're going to start seeing the VDX and the VCS fabric start to distribute that load across all three of these default gateways. So we'll go from one 10 gigabit Ethernet link to 20 and to 30 gigabit Ethernet links and spraying them all across the default gateways. Very unique in the industry, never been done before. Again, this is for n different gateways, meaning we have, we're showing 3 default gateways here. We can go even higher as well. So that's what we're going to be showing. Let's go take a look. All right, so we're back again, and we're doing the layer 3 active-active N gateway test. So this is really important for a couple of reasons. One is that this is an industry first in terms of having 3 active default gateways and even more that can simultaneously route traffic. So it's one virtual IP address, and it's load balanced across all 3 of them. Okay, why is it important? Mainly because of in very large data centers, when you have a lot of servers in lots of different virtual virtual LANs, you want to be able to route between the 2. So a lot of east-west traffic. So in order to avoid things like network tromboning and some weird traffic patterns, you can have a nice orderly east-west traffic flow with having multiple default gateways. So we're going to show how this really works. And I have Javan with me that's going to help me through it.
Hello. Hi, Nick.
Hi, Javan. Great, excellent.
Okay.
So the configuration is that we have 120 gig coming into a top-of-rack server, and that is pointing towards 3 default gateways, each at 40 gig each. So that's the configuration. John, let's take a look.
Let's take a look at that one. So here I've got 24 links, 12 connected to the top of the rack to the servers, and 12 going to the fabric. So let's look at the fabric first. So these are our ISL links.
And also for the audience as well, this screen over here represents the top of rack switch, and then these screens here represent each one of the default gateways. So
exactly,
please.
Yeah. So we have 40 gig to each of the gateways. Now what we will do, I'll show you the traffic that's coming in. So if we do show interface, the first 12 links have got the traffic coming in. So I'm gonna just highlight those.
Great.
So this is the traffic that's coming in into the fabric.
Right. So this is it's pumping traffic in, and we've actually set that at nearly 55%, between 55 and 60% utilization of line rate.
Yeah. Great. And that's and now I'm gonna show you the traffic that's going out. So that will be on the last 12 links. So show if we do check the output. Yep. So this is the traffic that's going out, and it's this traffic, right?
Okay,
so this is your traffic that's going out.
Great. So this shows the distribution of traffic leaving the top of rack switch destined to the default gateways. And so it's a little bit distributed. So we have 50% here, 80%, on a couple of links, and so forth. So a nice distribution.
Right. Exactly. And then I'm going to show you on one of the gateways how the traffic is coming in on those 4 links. So if we do the same thing, input, and this is the traffic coming in. I'm going to quickly zoom in and show you. So these are the 4 links where we are receiving the traffic. Okay, great. Okay.
So this is basically 40 gigabits worth of traffic, 10 gig each on 4 points, and that's the distribution coming in. So pretty uniform.
Yeah, exactly. So that's our layer 1 multipathing that's coming into effect. Now if I do this show interface, and I'm going to show you what is the traffic going out this interface. The same ISL ports, so that's your traffic going out. Let's zoom on that. So this is the traffic that's going out.
Very good. Okay, and also too, very nice distribution, of traffic.
Right.
Excellent.
Okay. Now on this one, let's take another look. So let's look at the traffic that's going out back to the Ixia. So that's your traffic that's going out. So you see these 12 links.
Okay, great. Excellent. Very good, very good. So these are, so in the Ixia gear we have, that's where the traffic was destined. It was coming in and it has to come back up to the Ixia gear.
Yeah.
Great, excellent. So we want to show you how layer 3 traffic can be load balanced and distributed across n different active default gateways. This is how it looks and this is how it's done. And again, this is extremely important in data centers to have nice, orderly east-west traffic flows and to avoid some strange kind of traffic patterns that result with having one default gateway and all the other gateways pointing to it. So, Javan, thank you very much.
Thank you very much, Nick.
Great, excellent.
That concludes this edition of the Lippis Report. Thank you for joining us. Look for us every Tuesday and Thursday. To get your free subscription to the Lippis Report newsletter, go to www.lippis.com. To sponsor the Lippis Report podcast, send email to sales@lippis.com. We've got to go, and so do you. See you next time.